In this video, I'd like to show you how to calculate the probability of dependent events using a tree diagram. For example, let's say there's a bag with 4 green marbles and 6 red marbles. Now, let's say you pick a marble without looking, and then, without replacing it, you then pick another marble. What is the probability that the first and second marble will be green? The first marble will be green and the second marble will be red. The first and second marble will be red, and the first marble will be red and the second marble will be green. Well, in each of these cases, we're calculating the probability of more than one event, which is known as compound probability. Now, compound probability is equal to the probability of the first event multiplied by the probability of the second event. So that's what we're going to do in all of these cases. We're going to calculate compound probability by finding the probability of the first event in each of these cases and multiply by the probability of the second event in each of these cases. Now, before we can calculate the probability of each of these events, I'm going to draw a tree diagram, which is a graphical representation that shows all possible outcomes of a series of events. So first, I'm going to draw 2 branches for the probability of the first event. One branch represents the probability of randomly picking a green marble, and the other branch represents the probability of picking a red marble. And along the sides of the branches, I'm going to write the probability of picking each. Now, probability can be written as a fraction, with the total number of possible outcomes as the denominator. So in this case, we have 10 marbles, so let's write 10 as the denominator for both probabilities. And for the numerator, we need to write the favorable outcome, which means the desired result. So there are 4 green marbles and 6 red marbles. So now that we've drawn the branches showing the probabilities for the first event, let's now draw branches showing the probabilities for the second event. Now, if you picked a green marble in the first event, how does this affect the probability of picking a green or red marble in the second event? Well, remember, in the first event, you pick a marble without looking, and after you pick the first marble, without replacing it, you pick another marble. And this means if you picked a green marble in the first event and you did not replace it, that the total number of possible outcomes changes. This means that these events are dependent, and that's because what happens in the second event is affected by what happened in the first event. So since the green marble was not replaced, there are now 9 marbles remaining in the bag. 3 green and 6 red. So now that we've drawn branches illustrating the different probabilities if we first picked a green marble, let's draw branches showing the probabilities if we picked a red marble first. Now remember, we've already determined that these events are dependent since you did not replace the marble before taking another marble. So, just like with the green marble, if you first picked a red marble and did not replace it, the total number of possible outcomes changes. So, since the red marble was not replaced, there are now a total of 9 red marbles in the bag. 4 are still green and 5 are now red. So we've completed our tree diagram showing all possible outcomes. Now let's use it to help answer all of our original probability questions, starting with the probability of picking a green marble and without replacing it, picking another green marble. Well, in the first event, the probability of picking a green marble is 4 out of 10. And in the second event, the probability of picking another green marble is 3 out of 9. And 4 out of 10 multiplied by 3/9 equals 12 out of 90, or 13.33%, which is the probability of picking a green marble, not replacing it, and then picking another green marble. And next, let's calculate the probability of picking a green marble and then picking a red marble. Now, in the first event, the probability of picking a green marble is 4 out of 10. And in the second event, the probability of picking a red marble is 6 out of 9. And 4 out of 10 multiplied by 6/9 equals 24 out of 90, or 26.67%, which is the probability of picking a green marble, not replacing it, and then picking a red marble. And next, let's calculate the probability of picking a red marble and then picking another red marble. Now, in the first event, the probability of picking a red marble is 6 out of 10. And in the second event, the probability of picking another red marble is 5 out of 9. And 6 out of 10 multiplied by 5/9 equals 30 out of 90, or 33.33%, which is the probability of picking a red marble, not replacing it, and then picking another red marble. And last, let's calculate the probability of picking a red marble and then picking a green marble. In the first event, the probability of picking a red marble is 6 out of 10. And in the second event, the probability of picking a green marble is 4 out of 9. And 6 out of 10 multiplied by 4/9 equals 24 out of 90, or 26.67%, which is the probability of picking a red marble, not replacing it, and then picking a green marble. If you like this video, please subscribe to Mr. McLean Math. And also, be sure to click all so that you get notifications when new math videos are uploaded. Thank you for watching.